Today we are doing lesson 3, day 1, the graph of the equation y equals f of x. Our goal is for you to understand how to write intervals for where the function is increasing and decreasing. First thing we're doing is completing warm-up 1. So you're given that L is equal to the square root of 2, M is equal to 3 root 3, N equals the square root of 16, and P equals the square root of 9, which expression results in a rational number. Key word here is rational. This means it contains the word ratio. It means it can be turned into a fraction. So we will see things like whole numbers. I could turn that into a fraction. I'll see things that are already fractions. I'll see terminating decimals. And I'll see decimals that will repeat forever with a pattern. What we won't see are decimals that go on forever with no pattern. If we find that, that's an irrational number. So the simplest way to start with this problem is to figure out which of these are rational and which is irrational. So if I come to my calculator, plug in the square root of 2. I see 1.44414, blah, blah, blah. If you don't already know, and you try to turn it into a fraction, it comes up with the same answer because it can't turn it into a fraction. It means this is irrational. So 3 root 3, do the same test. And again, it means it's irrational. Square root of 16. Yeah, if you know these, you don't have to take the time to plug them into your calculator. But what we should notice is that I got just plain numbers for each of these. Means they are rational. That was on our list. All these expressions in our answer choices are addition problems. If at any time any piece of your sum is irrational, the whole sum will be irrational. So you just have to find where the two numbers being added together are both rational. You find that here, n plus p. Moving on to our lesson. First thing that we would need to do, number 1, what is a linear function? What does it mean to be linear? Hopefully you know this already. What is the shape of a linear function? It has the word right there. So a linear function is a function that creates a straight line. The reason that it creates a straight line is because it has a constant rate of change. That is what is special about a linear function. That phrase, constant rate of change, is going to continue to come up for lines and linear functions. It's good to learn it now. We now need to create a linear equation, graph it, and then state the domain and range. So we can make up anything. We know a linear function has that format y equals mx plus b, so this is taking any number for m, any number for b. So maybe we will graph 4x minus 8. Y equals mx plus b. B is where we begin. My b in this example is a negative 8, so I'm going to begin at negative 8 on my y-axis. The m is my slope, how I move. I'm moving up positive 4 and over 1. Use a ruler. Points. Making sure I'm doing all my necessary graphing. Got my arrows on. Now we are doing domain and range. So by the nature of a line and what we know about it, what do we know? We know it's going to continue on forever in both directions. So it's continuing to go up and to the right here, down and to the left here. So does that mean there's any reason to restrict my domain or my range? The answer is no. It doesn't matter what I plug in for x, I'm always going to get an answer. And it never is going to matter. I'm going to get every possible answer out as an answer for the y. So with number 2, what is an example of a nonlinear function? Then create an equation, graph the equation, state the domain and range. So right here, it kind of tells you what it looks like, something that is not a line. So anything that's not a line, we would call a curve. So this is a function that creates a curve. So for my example, how about we do f of x is equal to x squared. We'll use our table feature of our calculator to get those values. My y equals, put in the x squared, taking a look at the picture. I can see it's got that symmetry around the origin, so I should look for that in my table. And then you can see the same thing here. So we're going to plot this from -3 to 3. Copy in the values out of the table. And then graphing, so -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. And then for the domain and range, again, thinking about the nature of this, we got to decide, do we have reason to restrict? So when we look at this parabola, what I see is while it's going up, it's also going out. So is there ever going to be a time when I plug in a number for x and don't get an answer? The answer that's no. It doesn't matter what I plug in for x, I always get an answer. So it's all real numbers and no restriction. For the range now, start with all real numbers like you're supposed to. Do I need to restrict? This time the answer is yes, because I only see a picture up here. So I need to show that the only answers I get start here and then go up from there. So how do I do that? All real numbers, but y must be greater than, because the answers are going up, or equal to, what was my lowest answer? 0. Now, like that. For the next part, we are going to have to describe and show the difference between increasing and decreasing intervals. So we'll make ourselves 3 coordinate planes here. So increasing, thinking about what we know with graphing, what does increasing look like? What direction is it going? You should have thought about increasing means it's going up. Draw a nice little line in, show increasing like that. Decreasing. What's decreasing going to look like? It should say going down. So a nice line going down. And then the tricky one, constant. What does it mean to be constant? So this is where we are not changing. We don't see it increasing, we don't see it decreasing. So that's just a straight, flat, horizontal line. When we turn and look at the next page, it's talking about minimums and maximums, and what I'm going to do is not do that today. We're going to save that for the next lesson. So you're turning to the homework. you were doing the entire front page, leaving the back for after our lesson tomorrow. So the 925 homework is just number 1 through 12. And all you are doing is writing where it is increasing, and you can abbreviate, decreasing, or constant, and you can write on each of the graphs. So for example, on number 1, I see this blue line here. I see it's going upward, and it's an increasing graph. Number 1 is done. So you're doing the rest of them, and then watching out for the part 2 video for lesson 3, day 1, where we will finish the notes. So making sure if at any time you are not sure, you need me to explain something further to you, you need help, you got questions, whatever the case may be, you got to come and see me so that I can help you out. Good luck. Watch for part 2.